Do you remember when the only way to talk on the phone was to be physically connected to a phone line in the wall? In case you're too young to remember, it was very restrictive, unless you had a really, really long phone cord. After many advancements, mobile phones came out, giving people the option to make a call just about anywhere. This can be compared to the accessibility of the internet. When it first came out, every device had to be connected to the internet with wires in order to work. Then, along came a game changer, Wi-Fi. This allowed Wi-Fi-enabled devices to connect to the internet without wires. Ah, the freedom. If you have ever wanted to know more about Wi-Fi, stick around a while. In this episode of Cisco Tech Talk, I'll introduce Wi-Fi, including its definition, benefits, components, and more. Next. Computers, smartphones, printers, video cameras, and wearables like smartwatches. All of these and more can connect to the internet using Wi-Fi, a wireless networking technology. Wi-Fi establishes a network by allowing these gadgets and many more to communicate with one another. A Wi-Fi network is a wireless local area network, WLAN, that employs Wi-Fi protocols. There are many Wi-Fi network benefits. I'll start with the benefit of an extended range. It makes computing possible anywhere, even with high data rates and sophisticated online applications. This characteristic offers comfort, an improved user experience, and the opportunity for new uses and applications. Another benefit that Wi-Fi allows is scalability. Assigning login information is all that is necessary to add users to a Wi-Fi network. Keeping it simple, there's no physical infrastructure left standing after users are removed. As mentioned earlier, Wi-Fi provides device flexibility, since Wi-Fi enables the usage of a variety of devices, including computers, phones, tablets, gaming consoles, and Internet of Things, or IoT, devices. Wi-Fi networks need a lot less hardware than conventional networks, so there is easier installation and maintenance. This saves money, speeds up installation, and frees up more space for networking gear. Network management is simplified with a Wi-Fi network. Administration can be carried out virtually, just like scaling. With specialized software, visibility, user management, network health monitoring, data collection, and optimization, adjustments may all be made through a single interface. Embedded systems allow Wi-Fi installed equipment, including IoT devices with no interface, a connection to the internet via a security standard called Wi-Fi Protected Setup, WPS. There are some architectural components that make up a Wi-Fi network that I'll go over, starting with stations. Stations are components that wirelessly connect to the network. Each station has a distinct network address that can either be an access point or an endpoint. A basic service set, BSS, is a collection of stations with network connectivity. When two or more wireless devices connect to one another in an ad hoc network without needing a router or access point, the group is known as an independent BSS. An extended service set, ESS, is a collection of BSSs that are linked together, such as in a network with numerous access points. A distribution system is a means of connecting access points within an ESS. These connections are either wired or wireless. A wireless distribution system, WDS, may use mesh or its own WDS protocol. Fixed wireless is a special form of radio transmission used to connect geographically separated access points. An access point is a base station that acts as a hub to which other stations connect. Access is the station's access to the network. ESS allows access points to be connected via Ethernet cables or wirelessly. Bridges are used to connect WLANs to LANs or access points. An endpoint is any end user station, a computer, a mobile device, printer, or IoT device. You may have wondered how Wi-Fi works. Like broadcast media, Wi-Fi carries information over radio waves. Data is sent in packets containing layers with labels and instructions. These instructions, along with unique media access control, MAC address assigned to the endpoint, allow packets to be routed to their intended destination. Wi-Fi standards are constantly evolving, but each subsequent upgrade is designed to be backward compatible with previous versions. Security is important, especially on a network. The most basic way to secure your Wi-Fi is to use MAC addresses to ban unauthorized stations. However, determined adversaries can join the network by forging an allowed address. Therefore, encryption is the most popular way to secure Wi-Fi. Several encryption methods have been introduced, such as those used in Wired Equivalent Privacy, WEP, and Wi-Fi Protected Access, WPA. As for authentication, WPA2 and WPA3 are currently the standard authentication methods. They provide acceptable security when strong passwords are used. Wrapping up, one last thing I wanted to go over is mesh as an option for a Wi-Fi network. A mesh network uses many access points wirelessly connected to each other. This extends the range and performance of a Wi-Fi network. Mesh networks offer multiple possible transmission paths and can use intelligent routing algorithms to manage routing and optimize performance. Mesh networks help solve the challenge of providing Wi-Fi in large public spaces such as libraries, convention halls, stadiums, and campuses. There you have it. Answers to questions you may have had about Wi-Fi. Connection options keep improving. I can't wait to see what's next. Thanks for watching. I'll see you next time.